Nurul Huda binti Abdullah. I am Nurul Afiqah Nabila binti Amirullah.
Hi, I'm Karimah binti Syafi'i.
I'm Tengku Nurwani Hairi binti Kosman.
Hi, I'm Siti Mishamadati binti Ramli.
Hi.
Assalamualaikum and hi class. So today I will explain a little bit about the concept of tangent and secant line. So basically, what is tangent and secant line? So from the graph shown, there's a line that touches the graph. But is that a tangent line or secant line? We doesn't know. So let's explore. So as we see here, this line touches only at one point. At this only one point. So this is a tangent line. Why? Because it touches only one point at the function. So that is tangent line. So how about secant line? So for now, as you can see here, this line touches 2 points at the function. So this line is called as secant line because it touches twice at the function. So what is the difference of tangent and secant line? Remember, tangent touches only 1 point, secant touches twice. So tangent once, secant twice. It's easy to remember because secant you can memorize like second, so second two twice, so second twice.
Hi students, now we will proceed to another subtopic which is limits. So what is limits actually? Okay, limits is a function. It is set to approach a constant L as the limit when x approaches A, like this. Can you see this now? Okay, actually we are not interested in the value of fx when x is equals to A, but we are actually interested in the behavior of the function when x comes closer and closer to the value of A. Okay, now I will show you an example for this subtopic, which is limit x approaches to 2x squared minus 2x plus 1. Okay, we have to substitute the value of x, which is 2, in this function. So 2 squared minus 2 times 2 plus 5 is equals to 5. Like I said just now, we are not interested in the value of x, but x is equals to 2. But we are interested in the behavior of fx, but x is getting closer and closer to 2. So, if x is equals to 1, so the value of fx is equals to 4. Now, let's take a look. When x is equals to 1.5, so the value of fx is become 4.25. And equals to 1.999. So the value of fx is equals to 4.998001. So the value is getting closer to 5. So now let us take a look if x approaches to 2 from the right side. Okay, when the value of x is equals to 3, so the value of fx is equals to 8. When the value of x is equals to 2.5, the value of fx is equals to 6.25. Until when the x is getting closer to 2, which is x equals to 2.001, the value of fx is equals to 5.002001, which is getting closer to 5.
Hello everyone, today I will talk about one-sided limits. The meaning of one-sided limit is the value of the function approach the s value for the limit from one side only. There has a two limit, one from the right side and one from the left. We limit of s approaching a from the right is equal to l, or limit s approaching a from the left equal to l. square over x plus 2 as approaching 2 from the left. So we substitute the 2 in the x and we get 4 over equals 1. B is limit x plus 3 multiply modulus x plus 2 over x plus 2 plus s approaching negative 2 from the left. So modulus x plus 2 we expand the modulus x plus 2 and we will get x plus 2 which is x for x greater and equal negative 2 and negative x plus 2 for x less than negative 2. And because of this is from the left, so we need to use this one, negative x plus 2. So we substitute it and here and we can cancel off of these two and we get limit negative x plus 3 x approaching to negative 2 from the left and we substitute negative 2 in the x and get negative 1. Okay, I will talk about two-sided limit. The meaning of two-sided limit is function of fx exists at a and only if both of the one side at a and half is 7, which is limit as x approaching a from the left equal to L equal to limit x approaching a from the right. Okay, get the limit of s approaching a equal to L and limit of s exists. Let me to start. Fx equal to 2s for s less than or n equal 4 and 2s plus 3 for s greater than 4. Okay, we do it on the line. This one here. 4 greater s plus 3 s equal to s 4 from the left. Fs x. We substitute for integral s and get 8. And then limit x 4 goes to x plus 3 and substitute 4 into and get 11. So because of limit x from the left is equal to x from the right. Apa is s negative 2 for s less than negative 1 and 2s is for s greater than negative 1. So we use limit s if 1 from the left is we use this negative 2 and x. Take 1 from the right is up here. Negative 1 in the right as you get. So because of s negative 1 equal to the right.
Hello everyone, today I want to teach you guys about infinite limit. Okay, what I want to say today, you can see in front of the board, limit x approaches to a from the left, function equal to positive infinity, and for the limit x approaches to a from the right, equal to positive infinity. If both of these we get the same and match, we can compute that as limit x approaches to a function equal to positive infinity, because both of these is same as if we from limit x approaches to a from the left, we got equal to negative infinity, and for this negative infinity. So here we get limit x approaches to a equal to negative infinity also. As you can see from the graph, this is function equal to 1 over x. You can see limit x approaches to 0 from the right, we put positive. And we put function here 1 over x equal to, from this graph, 1 over x. When it approaches to 0 from the right side, it becomes positive infinity. Right? Positive infinity. For this graph is also 1 over x, but it approaches to 0 from the left side and it becomes negative infinity. Right? We put negative from the left side. And the function 1 over x, we get negative infinity. So we can conclude that limit x approaches to 0, 1 over x does not exist. For now, let's see some example to understand what we learned today about infinite limit. First, I give you the easiest example for this infinite limit. We have limit x approaches to infinity, 1 over 3 e power of x minus 2. How we can solve this? Let's see. We can substitute the x with the infinity for this function. 1 over infinity minus 2. So we got 1 over infinity. So final answer is 0. Second, we have limit x approaches to negative infinity, x power of 4 plus x over 5x power of 3 plus 7. How can we solve this? For this function, we cannot substitute straightforward because this is a polynomial. We must divide all these function with the highest power of the denominator. Let's see the denominator, highest power is x power of 3. We write first is limit x approaches to infinity and x power 4 over x power 3 plus x over x power 3 divided by 5 x power 3 over x power 3 plus 7 over x power 3. Right back because we substitute yet. Is x power 4 over x power 3. We get this out 4 and 3, so we have x only plus 1 over x power 2 over 5 plus and 7 over x power 3. So when we convert this, we can substitute them. It will be more easier or more simple. X we substitute with negative infinity. This becomes 0 and this becomes 0. So we have negative infinity over 5 and negative infinity. So this is how we solve question about function of polynomial. Let's see this example. We have limit x approaches to infinity, 3x squared plus 1x plus 4 over x power of 3 plus 7x. This is also a polynomial, right? So we must do like this. We must divide all the function with the highest power of denominator. From here we can see x power of 3 is the highest power, right? Okay. 3x squared over x power of 3 plus 5x over x power of 3 plus 4 over x power of 3 over x power of 3 plus 7x over x. We can cancel out the x. Simple like this, we can substitute the x and this 0, 0 and this 0. This is also 0. Lastly, we have 0 over 1 and we get 0. Okay. Just like this, you can see how simple it is. I hope you guys can understand what I teach you guys today. Okay?
Hi everyone, today we want to learn about asymptote. So, have you ever heard about asymptote? No? So, what's asymptote mean? Asymptote is a straight line that constantly approaches a given curve of a graph, but that doesn't mean. Okay everyone, first of all, I want to teach you about vertical asymptote. So, what's the definition of vertical asymptote? Vertical asymptote is, as you can see in the graph, x equal to a, this one, is the vertical asymptote of a graph of a function y equal to fx. If either limit fx, x approaching to a from the right equal to positive or negative infinity, or limit fx, x approach to a from the left equal to positive or negative infinity. How we want to find vertical asymptote? There are two ways. First, make sure the function is in simplified form. Second, find the value of x that causes denominator equal to 0. So, let's do an example. Fx, x equal to x plus 3 over x plus 2. So, this is in simplified form, right? So, the second way is, we take out the denominator and equal to 0. So, we get x equal to negative 2. And then, we do the next step, which is limit. Limit x approach to negative 2 from the left, and then substitute the negative 2 in this equation, and we will get 1 over 0, but the 0 is negative, so equal to negative infinity. And then limit x approach to negative 2, but from the right, x plus 3 over x plus 2, you need to substitute, and then you will get 1 over 0 positive, equal to positive infinity. How we want to know about 0 negative or 0 positive? You need to do a number line, okay? So, we can conclude fx has a vertical asymptote x equal to negative 2. Okay guys, let's move to the horizontal asymptote. So, as you can see in this graph, this one is horizontal asymptote. So, we can denote is y equal to b, okay? So y equal to b is horizontal asymptote of a graph of a function y equal to fx if either limit x approach to negative or positive infinity equal to b. B is which is a constant. Okay? Let's move to the example. So this one, limit fx, x approach to negative infinity equal to 4. So this is a graph. So we know for y equal to 4 is a horizontal asymptote for this function. Okay? Okay, the second example is fx equal to x over x minus 2. So, if we do limit and we substitute positive infinity into the function, we will get what? We will get infinity over infinity, right? So, how we want to make sure we don't get infinity over infinity? So, we need to divide it by the highest power of the denominator. So, limit x approach to positive infinity. So, we divide x over x and then x minus 2 over x. Okay? And then we will get limit x approach to positive infinity in this form. And then divide, you substitute positive infinity, this one. And then 2 over positive infinity, you will get 0. So, 1 over 1 minus 0 equal to 1. Okay, same goes to this. Limit x approach to negative infinity, and then you divide all with x, and then you will get this one, and then you substitute negative infinity into x, and then you will get 1 over 1 minus 2 over negative infinity is 0. So, we will get 1 over 1 minus 0 equal to 1. Okay. The conclusion is, hence, y equal to 1 is a horizontal asymptote of fx.